So yeah, welcome to the Qball Data Lake Summit. I'm Prabhu Ganesh, CTO at MiQ Digital. Really excited to be part of this event. Obviously, we're doing this virtually in the current circumstances. So what you're going to hear in this session is basically our story over the last 8 years or so in building and scaling our data and analytics ecosystem. Right. So really delighted to be doing this session. Hopefully they are useful insights for you guys. I'm going to be sharing a lot of our learnings, decisions that we made, what worked well for us, what didn't work well for us. And hopefully, it's sort of a learning opportunity for every one of us. And, you might be in sort of different stages in building out and scaling your data and analytics capabilities. So a little bit of context on MiQ before we jump into the session, right? So MiQ is an ad tech company in the programmatic advertising space, and we have a decade of experience and expertise in running programmatic media campaigns for advertisers across the world, right? So we have traded over 35,000 campaigns across verticals, across several countries. We've served over 180 billion impressions across multiple screens and devices. And why are we better, right? It's because our expertise in bringing in data-driven decisioning in programmatic advertising. We process several petabytes of data, run various sophisticated data science and machine learning algorithms to decide what ad slots to buy at what times, targeting what kind of users in the right environment at the right price. So a quick glimpse of kind of advertisers we worked with, and we work across verticals, like I said. So let's deep dive into the data side of things, right? So the slide kind of brings to life, the different kinds of data sources that we work with, right? So we ingest over sort of 170 plus data sets, combination of streaming real-time data sets plus batch data sets, right? And we are able to, ingest data sets from a wide range of data providers, right? From our clients' first-party data sets to, log-level data sets from ad servers, DSPs, third-party audience, data providers, and then a whole range of, data sets around device graphs or location or, ACR data sets for TV, like macro data sets, the likes of, social media sentiment data sets, weather feeds, finance feeds, sports events feeds, right? So as you can see, it's sort of a wide range of data sets that we work with. And, our data processing capabilities allow us to pull out the right features, the right combination of features from across all of these data sets by unifying them and figuring out the right buying strategies to leverage on our programmatic campaigns. So just to give you a sense of the scale of our data platform that powers all of this, like I mentioned, we process several terabytes of data a day. We use our data processing outputs to power some 7,000 plus programmatic buying strategies, targeting over 750 million users across the world, whilst listening to more than 80 billion ad impressions a day, right? So that's sort of, just to give you a sense of the scale that we operate in. So whilst I'm going to talk about our journey, I also want to just point out that our journey has had its ups and downs, right? We didn't get everything right. Things that worked. There are things that worked well. There are things that didn't really work well. So it wasn't sort of like a red carpet path or a well laid out path up a mountain, right? We had those ups and downs, those things that we had to alter our course, right? And you might sort of experience that in your journey as well, and it's important to sort of recognize that. So let's go back, right, to the beginning, so 8 years back, and we'll start off with this whole debate around data lake versus data warehouses, right? So 8 years back, we knew that we had to build a data analytics platform, an ecosystem, for MiQ, right? And there were a whole a range of popular data warehouses that the likes of Teradata, Netezza, Vertica, and stuff like that. And there are popular ETL tools like, Talent, Informatica, and stuff like that, right? So, and then there was this sort of emerging trend of data lakes, sort of still in its early days back then, right? So the sort of the fundamental difference is, with data warehouses, data is sort of, well prepared, structured, right? And you store that in the data warehouse and then use the whatever processing capabilities that the data warehouse provides to be able to do various data processing on the data that you have, right? And the typical use cases are sort of insights, reporting, data mining, data analytics kind of stuff, right? Whereas in the data lake approach, right, you bring in the data as is. There's sort of no transformation or cleaning or anything like that. You store the data as is, and then based on your business use cases, your business requirements, you plug in the most relevant and appropriate data processing capabilities on that data, right? And these are sort of the usual scenarios or use cases that come up, right? Streaming analytics, interactive ad hoc experimentative analytics, right? Plugging in machine learning AI capabilities, as well as sort of automating the whole sort of data pipeline and pushing that to make business decisions. So yeah, so this was sort of the scene back then, right? And how did we sort of go about making these decisions? So first thing, sort of recognition, what was table stakes, right? Even sort of 8 years back, cloud-based cloud computing was fairly well established, right? If you starting to build something new, it was fairly easy to leverage the advantages of cloud-based systems. The pros of elasticity and scaling up quite quickly, right? And sort of the ease of use, we're all sort of reasonably well established that you would definitely consider that as an important factor. Obviously, the big data was also starting to find its presence. The dealing with sort of the V's of big data was also sort of expected, right? I think the third thing is organizations were no longer looking at data, and analytics as sort of a siloed piece of work that happens, as an afterthought, right? Or have sort of significant delays, right? It was expected that data, sort of turning them into insights and using those insights to power your business decisions, was the way that organizations could grow and scale, right? And the expectation was to be able to power that in real time or near real time, right? We didn't want to have those significant delays between data coming in, and then a week later some report appears, and then a month later some business decisions are made on that, right? That is just not acceptable, right? I think the fourth point was around democratization of data, right? It was also kind of expected that every business function or user had as much access to data in as much granularity as possible, right? And with all the relevant data tools and capabilities, so that they can turn the data into insights and sort of make their work more impactful and efficient, right? It was not sort of data and analytics was not restricted to a handful of people, like I said, in a siloed location, right? So this was sort of table stakes, and both data warehouses and data lake systems were ticking the boxes in all of these, right? So what are some of our key decision drivers? Like I said, data-driven decision was sort of key. And like I said, our USP was being able to unify several different data sources and figuring out the right combination of parameters for us. And we knew that, the kind of data sets that we had to work with is just going to grow, right? From structured to unstructured to semi-structured, and the scale of data was just going to explode as well, right? I think the other point was, though some of our earlier use cases were SQL driven, we knew that we had to plug in or support advanced analytics, right? The likes of, machine learning, AI, kind of data processing, advanced analytics, that was, is going to be needed, right? And I think data warehouses in general, they tend to support sort of SQL kind of processing. They're not, it's sort of harder to plug in these advanced analytics capabilities into an existing data warehouse system, or you might have to move data out of your data warehouse into some other system and do these advanced analytics process and sort of bring the data back in, right? So that was sort of, one of our key factors. The other aspect is, our business requirements were just, we anticipated they were continuing to scale, right? The number of use cases, we had to support for our clients and markets was just going to continue to evolve, right? Because data driven decisioning was again sort of a fundamental aspect of our business. We had to make sure that we are empowering the business with as much of the data capabilities as possible, so that we are staying ahead on this area, right? I think the fourth part was, we didn't want a rigid system, right? One of our key aspects of as a business is being sort of flexible. We understand every different advertiser is different. Their engagement with their users, is different. So, we didn't want to sort of say we could do only this kind of processing, or, we are limited to this look back time frame, and stuff like that, right? And we wanted to be, we didn't know all of the possible use cases and requirements that would come up at the point we sort of collect data sets, right? So we wanted to have that as much level of flexibility in our systems as possible, right? So these are sort of the key factors, and we decided to go ahead with a sort of a data lake approach, right? Um, so what is sort of our first version of our platform look like? Fairly simple. We had a data feed service which sort of ingest data from different data sources, put them in S3. We've been on AWS from the very beginning, right? Sort of leveraging AWS as a cloud platform, right? And yeah, like I said, we just bring data as in. We leverage sort of Redshift as a database to support some of our SQL kind of processing use cases at that point, and we were leveraging sort of EMR for some of our advanced big data kind of processing, right? Sort of Hive kind of querying on our data lake, right? And then our outputs were fairly simple at that point, right? For our non-analyst or non-engineering audience, sort of a simple UI to be able to pull aggregated data sets in whatever form, right? But then we were able to evolve this, right, significantly, right? And this is kind of a picture, sort of a few years back, maybe 5 years back, that we evolved to. Right, and as you can see, we were able to plug in a lot more data sets from different data sources. We were able to support both batch and real-time pipelines, right? And we were able to plug in a lot of open source big data engines, right? I sort of mentioned Hive, but then we were able to quickly evolve to, MapReduce, Spark, the likes of Presto, Tez, right? And then for some of our machine learning use cases, able to plug in Python and R, stuff like that, right? So that richness with leveraging all of these different processing capabilities and tool sets was fairly important for us, right? And then on sort of the real-time pipeline, we had fairly exhaustive capabilities there, right? So from the time a real-time signal hits our system to when we are able to make a business decision, right, sort of a matter of seconds, right? For example, social media sentiment feed from Twitter, being able to ingest that and sort of figure out trends based on that, and then using that as a signal to decide what ad slots to buy, or what how much to bid, and stuff like that, right? So that's the level of evolution that we had here. I think the other thing to call out is we also had to we were able to support both sort of interactive analytics for our analysts, data scientists, and we are also had sort of automated data pipelines that would run on certain schedules, for all our live use cases, right? And then sort of two ways the data outputs were surfaced. One is obviously through dashboards and visualization, but the most important thing, like I mentioned earlier, is being able to use these data outputs to power our business decisioning, right? And this enabled us to truly turn the data into insights into action. So the next stage of evolution in this is, we turned a lot of our data capabilities into a microservices-based API ecosystem, right? As you can sort of see, the three pillars of data management, data processing, and activation, sort of forms the core of this ecosystem. Each microservice was able to focus on one specialized functionality. Example, sort of turning something into Parquet file format, or extracting features using feature anchor or a segment service to be able to push a predicted set of segment into a buying platform, right? And this, whilst our set of data sources are just continuing to scale, and our integrations, how we activate on this data also continue to scale, we were able to quickly build a lot of data products on top of this data platform, that we were able to sort of surface to our internal and external users through our applications, right? And the key thing here is turning these data capabilities into microservices and API ecosystem allowed us to build out products and features as quickly as possible, sort of keeping pace with business requirements. So yeah, I think that's sort of this phase, and kind of taking a step back and looking at it, right? So what did this sort of journey allow us to do, right? And sort of in hindsight, it helped us keep pace with evolving big data technologies, right? I kind of spoke about how we were able to plug in new engines fairly quickly, right? Not everything worked well, right? There were sort of ups and downs there, but we were able to use the right technologies for the right use cases. We were able to quickly move from file formats, for example. It started off, it was just gzip, tab separated files, moved into ORC or Parquet or Avro, using the right kind of compression, Snappy or LZ4, and stuff like that, right? And we were able to also expand our use of different programming languages, right? So when we started out, it was predominantly SQL and Hive-based querying. We could evolve that into say maybe like UDFs, MapReduce jobs, and then we could in the last few years or so leverage things like Python, PySpark, Spark, even Scala, right? All of this is been possible because of the flexibility we had sort of in our ecosystem, right? And the next thing, like I said, we were able to pick the right tools and frameworks for the relevant use cases. For example, interactive dashboards, we figured out that Presto was sort of best suited for us, right? Given our kind of queries, and we were able to optimize our data formats in the right way, that we were able to do that, right? And for some of our complex machine learning pipelines where it needed complex joins across some of our data sets, we were able to sort of leverage Spark and optimize Spark to be able to do that, right? I think this was a sort of a key win for us, right? I think the third point, kind of going back to the warehouse and data lake comparison, right? With the data lake, we were able to sort of separate the data storage from the data processing, and that allowed us to sort of scale the storage and processing layers sort of independently. Obviously, storage is much cheaper. Processing is expensive, right? And like I said, at the time you sort of collect the data, not every single use case or business requirement is known, right? So this sort of separation and being able to scale it independently was also sort of a big win. If you, for example, if you had like a Hadoop cluster, you had to have the cluster running all the time, right? And it's sort of not data was not accessible if you didn't have the cluster running, right? So whereas with this sort of approach, we were able to separate out and scale them independently. And also there was sort of no unnecessary movement of data, right? Data resides in the data lake. We were able to plug in the data processing capabilities into the data lake as well, right? I think the last point is, kind of again looking back, felt like with this approach, our overall cost, in building out these platform capabilities is sort of lower, right? If we had gone with a data warehouse approach, I don't think there would have been sort of a single data warehouse system that would have matched all our use cases and requirements, right? We probably had to buy, leverage multiple systems, or deal with sort of movement of data from one to another, like I mentioned, right? And we feel this approach greatly helped us to manage costs significantly. So yeah, so let's move on to the next this thing, right? So we'll talk about our experience in managed services, right? So like I mentioned earlier, we started off using Amazon, EMR for our Hive kind of processing, right? And it was fairly simple to spin up clusters, leverage the capabilities there, and run sort of big data processing on that, right? But we also faced lots of challenges, right? For example, things like auto scaling or of the clusters was just not possible. Either we had to build in those capabilities ourselves, or wait for those in sort of the EMR roadmap, but some point, right? So we had to basically build in a lot of capabilities on top of EMR, if we had to leverage this truly, right? And I think this thing was the versions of some of these open source technologies significantly pacing behind, right, on EMR. So we were not able to leverage the best in class, right? And also the open source version of these platforms were sort of the vanilla versions, right? They're sort of not optimized Spark or Presto or Hive, right? And because of all these, like, sort of cost per processing unit was much higher in EMR, right? And then maybe 4 or 5 years back, we started moving to other managed providers, obviously Qbol being one of them, right? And it made a lot of sense for us from all of these aspects, right? I'll quickly talk about some of those key decision drivers. So I think the first thing is sort of a realization, that it's not our business to be managing clusters, building capabilities like, auto scaling, or, figuring out, the right optimizations in sort of, the underlying engines, and stuff like that, right? We are an ad tech company, and we're better off focusing our priorities towards our business requirements and our features, right? And we are better off sort of leveraging the likes of Qbol and sort of specialized providers for that, right? I think this other big point here is the cost optimization side of things, right? Like I mentioned, we wanted to leverage the right tool sets and engines for the right processing, right? And that enabled us to make sure that our costs per processing unit was as optimized as possible, right? And that, I think, was possible only because of sort of working with managed service providers. I think, like the last point, like I mentioned, is didn't want to waste the time of our engineers, analysts, data scientists troubleshooting issues, figuring out why this pipeline is not stable, it's sort of breaking, or debugging issues, and stuff like that, right? We wanted to significantly reduce that, and very confidently say that we were able to do all of this because of leveraging managed providers like Qbol. Okay, and I'm going to sort of illustrate this with a couple of examples. So first is an example of lookalike, predict segmentation job. This is one of our most sophisticated data processing jobs. It's actually a product that sort of won a data science award. It's one of the best in India, right? So when our sort of first version of this, you go back in time, this pipeline was predominantly in Hive, used to take about 24 hours, 28 hours to run, right? Then we optimized it, turned it, sort of map reduce jobs to certain UDFs, and optimized it as much as we could, and sort of bring it down to 8 hours, right? And then sort of moving it to optimize Spark, we were able to bring it down to 45 minutes, right? So as you can see, it's not just in terms of saving time and cost, right? But it also allows us to scale to business needs, right? I kind of spoke about that, right? Because earlier, if you look at the first version, 28 hours, we wouldn't have been able to run this job more than a few times a week, right? Whereas 45 minutes, we could run it several times a day, right? And it's one of the most complex, prediction job that we have, right? So that's the power, or how we were able to bring some of these things to life. I think the other example I have is sort of an insights dashboard. Our insights dashboards are powered by Tableau. Earlier, we used to have these dashboards run off Redshift data in Redshift, and fairly complex, comprehensive dashboards. A lot of queries, so it used to take about 5 minutes to load, right? Then we sort of experimented, played around with things like we did try Athena, we did experiment with Presto, and we were able to choose the right data formats, partitioning the right way, optimize the queries, and we were able to basically load the same dashboards in tens of seconds, right? And again, the benefit is not just the cost side of things. It also helps us to scale to business needs, right? Earlier, we would maybe have look back of only a month of data, right? Whereas with this, we were able to maybe go back to 3 months, right, or 90 days or whatever, right? I think it's how that sort of powered us. Okay, let's next talk about sort of cost management versus democratization. Is sort of one of my favorite topics. Like I mentioned earlier, right? Sort of democratization of data was sort of a given. Organizations and teams were expecting access to data as much as possible, right? And as an organization, we kind of over-indexed on this, right? We enabled our analysts, data scientists, engineers to spin up clusters they want, run whatever kind of processing, right? We had some basic checks like maybe like cluster idle time, or some sort of query timeouts, and stuff like that. Right, and the idea was to empower our users as much as possible, so providing them enough flexibility to meet our client requirements, and stuff like that, right? And to also keep pace, like build out new features as quickly as possible, right? But we realized sort of costs can get out of hand quite quickly, right, if you don't focus on it. And we had some shocking AWS bills, stuff like that, right? And I think sort of the realization that we had to find a better balance, right? We can't afford to have a user making not a intentional error, like join with not the right clause, and it ended up being a cross join running for several hours, utilizing cluster, and stuff like that, right? So we had to double down on with focus on it, and we did a few things, right? First was to balance our democratization by scaling our data engineers, and sort of getting them to work with different teams, them to optimize some of our pipelines. It's not reasonable to expect an analyst or data scientist to write the most optimized data pipeline job, optimize the queries, or the configurations and stuff like that, right? So we had to go bigger on that, right? Leveraging our data engineers and the expertise in that, right? We also started really automating a lot of our cost reports, tagging clusters, tagging every query with sort of product names, owners, and stuff like that, right? So that we could figure out what our big cost drivers were. And also the last part was realize that to truly sustain this, we had to have the cost ownership with the respective team, right? And actually, we have a sort of separate session in the summit by a couple of our engineers who going to talk about sort of deep dive on this, how we made our cost reports more self-serve for our teams. So please do listen to that. So yeah, the next aspect to talk about is adoption and usage. So I think it's whilst we built all of these capabilities, right? How did our sort of adoption usage look like, right? And like with any product, if something is better, it makes someone's life easier. Consumers and users will move towards it, right? Whether it was sort of moving from EMR to Qbol, or moving from Redshift to Presto, or moving from Hive to Spark, or Scala. All of that was fairly straightforward, right? We were able to scale the adoption usage fairly quickly because it just better tools. Things were faster, or more functionality, or whatever, right? I think on the flip side, think also realize that as we were sort of going through all of this evolution and changes, important to plan sort of for migration and sunset of existing frameworks or technologies as well, right? Think of it like API deprecation, right? You can't sort of suddenly switch off something, right? There are production pipelines which had to be sort of tested with rigor. We sometimes had to write some migration tools, and stuff like that. So fairly time consuming efforts at times, but basically the takeaways, some of these need planning, right? I think the third thing I want to mention is, as we're building out a lot of our data science capabilities, right? We approached it like as building as generic capabilities, and then sort of trying to find business use cases that match those, right? And that didn't really work. Right, and sort of our recommendation is sort of approach it the other way, right? Start off with business use cases and requirements, figure out what features you might need, right? And then sort of try to generalize, generalize that into a service or capability, right? I think that kind of works much better, because there are specific use cases that are shaping your product features, right? Cool. Okay, so the next area I want to talk about is an area that probably doesn't get talked about much, is in terms of people and skills. Like, what's been our experience in this, right? So all of these three areas, right, in this ecosystem: data scientists, analysts, data engineers. These roles have kind of evolved significantly over the last decade, right? And when we sort of in early stages, we operated our sort of team structure more in siloed functional teams, right? But then when we sort of moved them to more of cross-functional collaborative teams, we felt it worked much better, right? We didn't we were able to sort of leverage each of these functions and roles for their areas of expertise, but also enable strong knowledge sharing, best practices, upskilling, right? We were able to train our analysts and data scientists in some of the new technologies fairly quickly, get them to understand some of the best practices, whilst having the data engineers as part of these teams, ensuring that they are owning the software engineering best practices, right? Whether it's sort of performance related, or reliability of the pipelines, or security aspects even, right? So the data engineers were able to bring in all of that software engineering best practices, whilst we were able to sort of upskill some of these other roles like analysts and data scientists. I think the other thing to also talk about here is it's important for data engineers to also put themselves in the shoes of the analysts and data scientists. It's not when so building a data pipeline is not just good enough to build a pipeline that works end to end, right? It needs to do what is sort of expected. So going back to things like definition of done, right? Like you would have those in your in your applications or software product features. It's important for data engineers to understand what is sort of expected, right? And makes it easier if they are able to relate to the overall product features, and put themselves in the shoes of the analyst or data scientist. And we also enabled a lot of internal moves. We've had analysts move to data engineers roles, data scientists who wanted to use some of their engineering background and move to data engineers, and also sort of the other way, right? Analysts or data engineers moving to data scientists. It enabled quite a strong culture of people wanting to do what they're sort of excited about. Okay, so yeah, I think the next important piece to talk about is sort of data governance, right? I think obviously the last 2-3 years with the likes of GDPR, CCPA, right? This has become a strong focus area. When we started off, like this is not as much of a focus area, right? We had limited controls on data access. A lot of our the open source big data engines also did not have that as a strong focus area, right? Sort of permission based controls, authorization access, and stuff like that was not a primary driver, right? And obviously with these compliance regulations and data privacy are here to stay. It's just the way the world is going to evolve. And we had to sort of spend a lot of time on this, right? In being able to adapt to it, right? It's sort of a fairly significant effort. I look at it as like a business debt, like something like a tech debt. We had to redesign some of our data storage processing capabilities, right? Integrate with the right frameworks to bring in necessary controls and permissions, right? And sort of going forward, ensure sort of data privacy by design, like security, it's not sort of an afterthought, right? It's sort of at the early stages of product scoping, right? I think we were able to bring in those changes gradually, right? And it's sort of important to recognize that these kind of changes do happen, and as an ecosystem, as a platform, we need to be able to adapt fairly quickly. Okay, so yeah, I think that's sort of been the story of our journey so far. I'm just going to spend a few minutes talking about what some of our future trends that we expect. Right, some of them might be specific to our domain, but some of them are broader as well. Right. So one thing is we kind of expect this sort of data lake analytic ecosystem to happen in sort of multi-cloud or multi-lake environment, right? So what I mean by that is, obviously in programmatic space, we have what we call as wall gardens as emerging, right? So there is the open web, and there is sort of what we call as closed web, the likes of Google and Amazon, right? Their advertising platforms tend to be sort of wall garden environments. They want data to reside within those systems, not move out, right? So how do you sort of scale your data analytics ecosystem without having to rebuild for every single environment, right? Figure out what can be multi-tenant or multi-cloud enabled versus what might have to be sort of cloud specific this thing, right? So I think you're sort of figuring out, obviously started working with Google cloud environment the last year and a half, 2 years or so, and we see this as a trend. We expect that to happen with more and more walled garden environments in the future, right? The next piece I'm going to talk about is, well, I sort of spoke about data engineering as a niche skill, right? I expect this to get more democratized. The analogy to think about is maybe 15 years back, right? DBAs or SQL experts, were niche, sort of niche skill set, right? But then later on, software engineers, picked up a lot of these things, right? So earlier, maybe schema had to be designed by a DBA, queries had to be optimized by SQL experts, stuff like that. Whereas now, nowadays, engineers are able to do that themselves, optimize the queries the way sort of relevant for their use cases, right? Sort of see a similar pattern. Obviously, data engineers will continue to exist there. They continue to be important, and as the function as the functional experts, but expect software engineers to pick up more of these skills and sort of get more familiar with leveraging these, right? Third piece is what I call as data ops or ML ops. This has also been there for a while, but still, it's sort of still in its early days, I would sort of say, right? This is like the whole DevOps for data pipelines or machine learning pipelines, right? So think of it as CI/CD like you have for your products and features, being able to run automated tests, push things to production, roll back, and stuff like that, right? So that whole pipeline as automated as possible. We are still not there, right? I don't think there are sort of strong frameworks that do this end to end. There are manual interventions in between. Sort of see this as a continuing focus area, right? Or a trend, and we expect some developments there. The last piece mentioned is sort of edge analytics, right? Again, this sort of there as a topic the last few years, and kind of expect this to continue to be a trend for the future, right? As more and more IoT sensors continue to grow and scale, our mobile phones become more and more powerful, right? Edge devices on corporate networks become more enabled, right? What analytics can be pushed to these edge devices, and not having to push every piece of data information to the cloud, and sort of try to decentralize analytics as much as possible, and leverage as sophisticated data science, deep learning capabilities, on these edge computing devices, edge analytics as possible, to find a sort of better balance. I sort of see this as a trend as well. Okay, so yeah, I think that's what I had for today. Really, excited to have done this session with you. Looking forward to any questions. Thanks.